Consider the following statement. If it is sunny, then the children will play outside. We have two propositions here. It is sunny and that the children play outside, and they are connected by our if-then statement. If we could state this in more formal logical terms by letting P stand for it is sunny and the letter Q for the children will play outside, then this would give us the conditional statement, if it is sunny, then the children will play outside. Or more formally, in logical terms, if P, then Q. If P happens, then Q will also happen. These if-then type statements are called conditionals, and reasoning about them is, as I said earlier, known as conditional reasoning. There are four inferences typically associated with conditional reasoning, and I want to look at them now, and I will tell you which are valid and which are not before we look at how people actually reason about these statements. If you are given a conditional statement and told that one of the constituent propositions is true or not, then you may be able to conclude something about the remaining proposition. Again, let me elucidate this with an example. You are told, if P, then Q, or if P happens, then Q will also happen. And you are told that P is true, or that P has happened. You are now able to conclude something about the remaining proposition Q. This all sounds very complicated and rather odd, so let us put it into the example that I used earlier. I tell you the following statement. If it's sunny, then the children will play outside. You look out of the window and you see that it is indeed sunny outside. What can you conclude from this? I'm hoping that you are all thinking that the children will play outside. I really hope you are, as children as young as 3 or 4 can do this, depending on the content of the problem. Thus, we have in purely formal terms the following idea. If P, then Q. P is true, therefore Q must also be true. Now we can use formal tools from logic, known as truth tables, to assess whether this conclusion is valid or not. But for the time being, I'm going to ask you just to believe me. Thus, if we give our participant the statement, if P then Q, and we tell them that P is true, then they should conclude that Q is also true. And anything other than that conclusion would suggest that they are not reasoning accurately. The inference that we have just considered is the easiest of the inferences to draw, as we will see later. And it's known as modus ponens, or MP for short. The next inference I want to consider is, rather confusingly, known as modus tollens, or MT. Here we begin with the same conditional statement that we used earlier. If P, then Q. However, the next piece of information given here is different than the piece of information we had earlier. This time, we tell our participants that Q is false, or that Q is not true. Or in terms of our example that we used earlier, if it is sunny, then the children will play outside. This is the same conditional statement that we used earlier. However, the second piece of information is different. Here, we add the information that the children are not playing outside. In this case, it is logically valid to conclude that it is not sunny. Again, in our formal P and Q type terms, this gives us the following argument form. If P, then Q. Not Q, therefore not P. These are the two valid inferences that are associated with conditional statements. But there are two further inferences that we need to consider. Under the normal interpretation of conditional statements, these next two inferences are invalid. Confusingly though, this is not always the case, as conditionals can be interpreted in two different ways. I don't wish to go into too much detail about this here. The reality is that sometimes these are valid and at other times not valid, depending on the interpretation of the conditional statement. The first of these two inferences is known as affirmation of the consequent. You'll sometimes see it referred to as AC. As ever, we begin with the conditional statement. If it is sunny, then the children play outside. But this time, the additional information, or the second premise, is that the children are playing outside. From this information, you may then draw the inference that it must be sunny outside. However, under the standard interpretation of the conditional statement, this is not a valid conclusion in purely logical terms. It may be true or it may not. That means that the argument form itself is not a valid argument form. It is not truth-preserving. Once more, for the sake of consistency, in formal terms, the argument looks like this. If P then Q, our standard conditional statement, you're then told that Q is true, and the conclusion likely to be drawn is that P is also true. Remember, under the standard conditional interpretation, this is an invalid argument form. The final inference to look at here is known as the denial of the antecedent inference, or you may see this referred to as DA. Again, we begin with the conditional statement, as ever. If it is sunny, then the children will play outside. This time, the next piece of information given is that it is not sunny. The conclusion that you may be tempted to draw from this information is that what has happened is the children do not go to play outside. As is the case with the affirmation of the consequent, this is an invalid argument form for the same reasons. It may be true, but it may not. Knowing that it is not sunny does not tell us whether the children will play outside or not. Finally, again, just to be consistent, in its formal guise, the denial of the antecedent inference looks like this. If P then Q, our standard conditional statement, not P, and the conclusion that is frequently drawn is that not Q is the case.